Alright, so we're going to go over the review sheet that you were given in class a few days ago. Alright, so for this one, your vertex is the opposite of this number here and this number as is. So your vertex is going to be at -1, -5. Your axis of symmetry is always x equals your x value. Domain of all quadratics is -infinity to +infinity. Your range is always your y value to whatever direction it's pointing. So if this is a positive number, it's going up. So your range is going to be from -5 to +infinity. You're going to increase. If it's opening up, you're going to increase on the right side of your graph. So you're going to increase from -1 to +infinity. Your increase of decrease always include your x value. Since you're opening up, you're going to be decreasing on the left side, so -infinity to -1. And to graph it, just to be sure we're on the right track, we're going to go -1 to -5. And we're going to increase it by 2. So over 1 up 2. It increases. Alright. The vertex of this one we still need to find. The best method, I think, for finding these things is using the table function in your graph. So on my calculator, I'm going to hit table. Well, first I'm going to turn it on. And I'm going to hit the table function. I'm going to plug in this equation into my calculator. So we'll clear that out. And we're going to do -x squared plus 4x. And double check that is right. And we're going to go and look for our vertex. And our vertex happens to pop up on the screen, but if it would have shown up right there, what I would have noticed is that the -5, 0, 3, the outside numbers aren't the same. So I want to scroll down until the top number and the bottom number are the same. So 0, 4, those aren't the same. 3 and 3, those two match each other. That's where I know my vertex is in the middle of those two. So my vertex is at the point 2, 4. The axis of symmetry is always the x value of your vertex. Your zeros are where it crosses the x-axis. These are places where y would equal 0. Well, if I look right here at this y value, that's 0, 0. And if I scroll down the other way looking for zeros, it's at 4, 0. Okay, of course you could always graph it. You go to the point 2, 4. And at 3, you're at 3. At 4, you're at 0. Up here at 1, you're at 3. And then at 0, you're at 0. So you can connect those dots that way as well. That way you can see your zeros or x-intercepts. Your y-intercept is at the point 0, 0. You're increasing on the left, so you're going to go from -infinity to 2 as you're increasing. -infinity to your x value in your vertex. You're decreasing on the right, so we're going to go from 2 to infinity. Describe the transformations of this function. The first thing I'm going to notice is the vertex has moved out of its home at the point 0, 0, and it moved to the left 2, and it moved up 4. So left 2, up 3 places. Alright, then we notice it's flipped upside down. So the way we describe that mathematically is reflected. And now we want to see if it's stretched any. And this is a part that bothers a lot of people, but I'm going to go over 1, and I'm going to go down until I touch graph. I had to travel down 1, 2, 3 places till I touched graph. So that means it was stretched by 3. So stretched by 3, I write the 3 out in front of the parentheses. Reflected makes that negative. Left 2 means I write x plus 2 because I go the opposite of what it sounds like. The squared is always there, and up 3 is a plus 3 on the end. It asks some other questions like what are the roots of this graph, and if I look here it's at -1 and -3. And then my average rate of change from -3 to -2. So in this window of space, what did my graph do? Well, it went up 3 places and over 1 place, so the rate of change is just 3. I could have written 3 over 1, but it's just 3. Alright, so for this quadratic equation, it wants you to sketch it using the given information. So it tells you your domain is all real numbers, it tells you your range is everything less than 4, it tells you it's increasing from negative infinity to 2, so it's increasing on the left side and it's decreasing on the right side. So for this one, I'm going to find my vertex by looking at the range and the intervals of increase and decrease. So when I look at the range and intervals of increase, I know that this value is my x value in my vertex and this value is my y value. So my vertex is at the point 2, 4. So 2, 4. Okay? It is increasing on the left side or going up on the left side, and it is decreasing on the right side or going down. And also if I looked at my range, it said it was everything less than 4, so this would be its highest point, meaning it would be going down from there. Describe the transformations to the parent function. This means it is reflected. This one means left 2 places, and that means down 2 places. Or excuse me, 5 places. That's all that means. This one, your 3, means it was stretched by 3. That one right there is right 4. This one's up 2. Now we're going to go backwards and we're going to write an equation based on the transformations. So if it was down 1, it's whatever it was minus 1 at the end. Shrunk by a factor 1/2, that 1/2 is going to go up front. It did not move left or right, so I don't need parentheses, I just need to fill in my x squared. This one was reflected over the x-axis and right 2 places. Okay, so you can put a y equals out there just to complete it as an equation. This one is asking us to go from vertex to standard form, so we're going to write our 2, and we're going to write our x minus 1 twice, plus 4 on the end. You cannot distribute the 2 now. You need to distribute your 2 binomials first. So 2 times x squared, and then x minus times negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is plus 1, plus 4 on the end. This is the point where you want to distribute. Okay, not before this moment, at this moment. So that becomes 2x squared minus 2x plus 2, and then your plus 4 comes down. And your answer is what you get when you combine all your like terms. 2x squared minus 4x plus 6. Do the same thing here. Put your negative and put your x plus 4 twice. Then your minus 6 on the end. Square it, so negative x squared plus 4x. Nope, excuse me, not negative. Plus 4x plus 4x plus 16 minus 6. Distribute your negative. Not before this point, at this point. And notice the mistake that I made. I didn't draw my parentheses right off the bat. That could have messed up a lot. So negative x squared minus 4x minus 16 minus 6. Now you're going to combine your like terms. You get negative x squared minus 8x minus 22. This equation here, we want to change it to vertex form. So the first thing we're going to do is put parentheses around my terms with x's. I'm going to undistribute negative 3 because I don't want anything to be in front of my x. So we're going to go negative 3 x squared minus 2x. It becomes minus 2x because that's what it would have to be before negative 3 was distributed to make it positive 6. Now is where I do my shortcut, and I just write x minus 1 in here, squared, my loop-de-loop. Negative 1 squared is 1 times negative 3. I'm going to subtract off whatever I get when I do that. So 1 times 3 is negative 3. So 2 minus negative 3 is plus 1. And you're done. That's the answer. For this one, I'm going to put parentheses around the terms with x's. I'm going to undistribute that 2. It's a positive 2. Now we're going to do our shortcut. X plus 2, because 2 is half of 4, squared, plus 1. No, we don't know what it's adding to it yet. We've got to do our loop-de-loop. 2 times 2, or 2 squared is 4. 4 times 2 is 8, so we're going to subtract 8. So it's going to be minus 7. Okay, an object is projected into the air and it gives you the formula. Okay, this is your height. T is time in seconds. Okay, so what we're going to do is asking about when's it changing directions, what's the maximum height. What it's looking for is the vertex. So negative 16 t squared plus 96t plus 160. I'm going to change it to vertex form. Now you could also plug it into your calculator and look at where it mirrors each other and figure out where your vertex is that way. I'm just going to change it to vertex form. Negative 16 comes out, I get my t squared plus, and then 16 divided into 96 will be negative 6t plus 160. So we're going to go negative 16, now we're doing the shortcut. T, and then half of negative 6 is minus 3 squared. 3 squared is 9. 9 times negative 16 is negative 144. So when I add 160 to 144, I get plus 304, making my vertex at the point 3, 304. This means that it changes directions at 3 seconds after it's thrown. The maximum height of the object is 304 feet because it's a max at the vertex. Describe the location of the object at 2.5 seconds. This is where if you put it into your calculator, you're already a step ahead. If not, you need to put it into your calculator. So we're going to say negative 16x squared plus 96x plus 160. I'm just putting back in that standard form. As you can see, that's just the standard form that it initially gave me. You could put in the vertex form. I'm going to keep hitting enter. So at 0, I am at 160. At 1, I'm at 240. At 2, I'm at 288. Oh, and then it jumps straight to 3. You've got to go and plug in, telling it you want it to be at 2.5. So I'm going to start at 2.5. I'm going to hit OK. And at 2.5, it's 300 feet in the air. So describe the location at 2.5 seconds, 300 feet, and rising. It's still going up because this is 3 seconds and 2.5 seconds is over here. Alright, so then it asks about what about at 4.1 feet. So I don't have to change anything, I just do 4.1, enter, 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 and that's going to be 284.64 feet. So it's 284.64 feet in the air and falling because it's past the vertex. On the next one, it gives you a table and it says it wants you to find a quadratic regression equation to model the max load given at the given height. Now I added in some multiple choice. I'm going to zoom in on them because they're hard to see. I added in some multiple choice because that's the only way we're going to be able to do this. Your calculator does not have the functionality to produce these types of equations. So the best that we're going to be able to do is give you equation options, which is the only thing the EOCT is going to be able to do. We're going to give you equation options, and then you need to plug in the x values and see which one gives you the best y values. So if you go through the list, and I'm going to go to my calculator now. I'm going to zoom out so you can see what I'm doing on the calculator. I'm going to go to my table, and I'm going to start with the first one. We're going to clear that off. So the first one is negative 127.5x squared minus 961.5x plus 5474.5. Alright, so I'm going to plug all that in, and I'm going to start it because this starts at 4, I'm going to ask it to start at 4, not 4.1. It goes up by 1 each time, so I'm going to let it go up by 1 each time. So it's going to start at 4 and step up by 1, and I'm going to go okay. Now I'm just looking to see, did these y values match those? Not even close. So now I need to check the other one. Well, the good news is the numbers are all the same, it's just the signs that are different. So I'm going to go in, instead of having negative 127 minus 961, I'm going to change those both to positive signs. So go to my table, they're already there, I just need to delete the negative sign and change that minus to a plus. Okay, so enter, 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 still starting at 4, nothing's changing, compare. Nope, those are not the same thing either. So obviously I only have one option, C. You're going to have 4 options on the EOCT and the test if this type of problem is on the test. And then, so I'm going to go back to my table, and then the only difference between this one is the 961 is positive, but now the 127 is negative. So I'm going to insert a negative sign and hit enter, enter, enter. Still start at 4, still step up by 1, and now I'm going to compare. Now they're not identical, they're pretty darn close. The closest one wins. So in this case, our answer is going to be C. Okay? It's a quadratic regression model. By nature, these are not perfect. If you remember the scatter plots that we did, that had a bunch of different dots, and we drew a quadratic in them, it didn't hit every dot on the mark, but it was close to all of them. Alright, so now it says use that model to predict what the max load would be at 8. Well, I'm already here at my table. I'm at the right model, so I'm just going to scroll down until x equals 8. And I get 5,006.5. So in the nature that they did, rounding everything to the nearest tenth, I'm going to say 5,010. And then that's pounds. That's all that's looking for. And then last but not least with this one, it wants you to find the vertex. I would put it into my table, so I'm going to clear the hard one out and put negative x, whoops, not negative squared, negative x, oops, clear all that out, clear, 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 negative x squared plus 4x plus 6. Enter, 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 enter. Now it's starting way up at 6. I don't see any kind of mirroring, and they're only getting worse, more and more negative. Wait, 6 to 1. Negative 6 and positive 6 don't count. Oh, there's a 9, 10, 9. They match each other, so your vertex is at 9, 10, 9. Nope, not 9, 10, 9. But what's the x value? 2, 10. Okay. Your vertex here, you look for that mirroring. It's right between these two, so your vertex is at 4, 6. And then right here, you look for the actual points. That's going to be 3, 9. Alright, and once the y-intercept, I'm just going to plug in zeros for this. Your y-intercept is just going to be at 6. 0, 6, not 6, 0. Your y-intercept here is where x equals, so this one right there is going to be your y-intercept. Your y-intercept here is at 0, 0. So this is your vertex. This is your y. Alright, and it wants the average rate of change from 1 to 2. Well, you already have your 2 point here. So when x equals 2, my y value is 10. When x equals 1, my y value is, well, calculator says 9. So I'm going to use the slope-intercept formula for this. So 10 minus 9 is 1. 2 minus 1 is 1. My rate of change is just 1. For this one, from 1 to 2, I'm going to look at these 2 points. And I'm going to say negative 2 minus negative 12 over 2 minus 1. Well, that just works out to be 10. So my rate of change is 10. For this one, at the point 1, I'm at this point right here. And at x equals 2, I'm at this point right here. That is up 1, 2, 3 over 1. So your rate of change is 3. That's the review packet. Last thing I wanted to show you is this one. If you're doing in behavior, all you have to look at is your A. So if I asked you, What is the end behavior of negative 1? Well, that's the equation from one of our multiple choice options. That's big and it's scary looking. Don't freak out. Just look right here at the fact that that's negative. That means your graph opens down. So on both x ends, whether x is decreasing or increasing, on this end or on that end, both of your functions are decreasing or going down. Same thing here. What's the end behavior for this function? It gives you something weird looking up front because it's a decimal, but it's a positive decimal, so that means my graph is opening up. So as x is increasing on this end over here, my graph is increasing. X is decreasing, my graph is still increasing. So that is how you would handle a problem like that, just as demonstration.